Okay, hello, last session of the day. Hope everybody's doing well, and thank you so much for coming to CARTO Locations New York. It's been really great to see all the people that came and all the conversations that are happening. And as CARTO employees, it's really awesome for us to meet all of you and see the different ways that you're interested in using the things that we work on. So as Flo mentioned, my name is Mamata, and I am, need to find the switch here. I'll just practice one time. Okay. Oops. Sorry. Okay, anyways, my name is Mamata, and I am head of cartography at CARTO. And so we're here talking about location intelligence, and just if we think about it in a broad context, really what we're after with location intelligence is taking raw data and extracting insight. And I'm actually lucky that I went after Stuart, because this middle piece here, he talked about quite a bit from the analysis perspective. But really, in order to go from the raw data to the insight, you need to gain information. Is it possible to make the slide bigger and the notes smaller, by any chance? Thank you. Okay. And so Stuart did a really great job of talking about how to extract value from data using analysis. And what I want to talk about is how cartography facilitates this process also. And not just the process of exploring the data, but actually the actual presentation of the insights. So when we think about cartography for location intelligence, we actually might not think about it so much. We might not really understand right away when we're looking at a map how critical the presentation of the information is to communicating the message. So I want to just kind of go through a few different maps to show some examples of cartography for location intelligence. And instead of saying location intelligence so many times, I'm going to say LI. And so one of the use cases is for storytelling. A lot of times the maps that we're making are just to tell a story. So here's an example of a map that is showing mass shootings that have happened between 2000 and 2018 in the US. And to be completely transparent, this is only, the latest shooting on this map is from February 2018. So for better, well, unfortunately there's been more since then, but they're not currently displayed on here. But I want to talk about how this map is telling a story through the cartography. So if we start by looking first at the legend, we can see some information that starts to help us interpret the symbols on the map. So we can see that the maps are sized by the number of people that were killed in each incident. And then a red dot indicates, a smaller red dot inside of a larger circle indicates shootings where there were more than 10 fatalities. And we've also done some other things to help communicate this message, like also label the places that have had more than 10 fatalities. So without really doing much else other than looking at the legend and kind of relating that back to interpreting the map, we can pretty clearly see that the largest mass shooting since 2000 was the one that happened in Las Vegas. Now, if we want to actually get more information, so we were looking, the story was about all of the shootings, But what if we wanted to narrow that down? What if we wanted to look at shootings that happened with legally attained weapons by people with prior signs of mental health issues? We can use this information panel on the right-hand side to filter, and then we get a completely new map. And on this map, what we see is that the largest shooting with legally attained weapons and prior signs of mental health issues happened in Virginia Tech. And we haven't had to reinterpret the map symbology. Another common use of location intelligent LI applications is for situational awareness. This is an example of a map that we made during Hurricane Irma. And this map is basically reading in live data feeds, or it was, I should say, reading in live data feeds from the USGS for wind speeds and the hurricane track. And then we also brought in data from the Center for Disease Control with a social vulnerability index. And so we made this map at one day, at one time of the storm. And during that time, we had to make sure that you could see the wind speed data, that any counties that were being affected by wind speeds were visible on the map, and that you could basically easily interpret and see the situation as the storm progressed. And this map was as dynamic as the storm. So it was even hard for me to get some screenshots to show how this kind of progressed. But for those of you that are familiar with Hurricane Irma, you might remember that every day it was changing. Some days it was going to be hitting some states, other days it was going to be hitting other states. And so when we're thinking about something like crisis management, the last thing that we want people to have to do is to reinterpret the map. So we're working with live data, live cartography, and making sure that no matter what state the map is in, that it's interpretable by the end user. LI applications can also be used for decision making. And I'm using some probably maybe not traditional location intelligence examples here, but this is a map that we made for the 2017 solar eclipse. And basically this map is meant to be a decision-making tool. So whereas in the previous two maps we were infusing symbology and communicating things through colors and sizes and things like that, in this map, not so much. We're presenting the information to the user so they can make a decision. And this map was particularly for a user to figure out where they wanted to go based on the viewing preference. And unlike the other maps that we've seen, the way a user would interact with this one is by starting on the right-hand side with the information panel. So they may start with where they live. In this case, this person lives in Oregon. And then what happens is the map updates to show only the viewing locations that are in Oregon. And then they choose the phenomenon of the eclipse that they want to see. And then the map begins to filter down more to give them some options. And I think at the end, they've chosen to go to Unity, Oregon. LI applications can also be used for analytic exploration. And I think Stuart did a really good job of kind of going over this process and how important it is. But from a cartographic perspective, you might make a map that is showing one thing. So here, this is a map of a development around Union Station in Denver, Colorado. Union Station is the black dot there in the middle. And what we have here are a 20-minute walk polygon around in 5-minute increments. And within each one of these, or within the total 20 minutes walk distance, you can see the information about the development, summarized there on the right-hand side. But that's the map that I made, and maybe somebody else wants to actually explore something else. So for example, if somebody wanted to see, okay, what's the development that's happened within a 5-minute walking distance, and more than the year the parcel was built, I'm more interested in seeing what kind of development it is. Proper cartography supports that as well. So I'm talking a lot about this kind of data exploration process, and where we are today, which may actually be different than it has been in the past, is that data exploration has typically usually been for the author of the map, but now we're also seeing through the examples that I just showed how data exploration is also happening by the map user. And so I want to talk a little bit about how a tool like CARTO Builder facilitates this data exploration process from both kind of perspectives. So starting with the map author, this is very typical, and this is probably where we all start. We have a data set. In this case, if you use CARTO, you've uploaded it to your account. And you can see that there's a lot of different attributes. This table that we're looking at here is just a screenshot of crop loss by county in the US in the year of 2017. And so there's so many rows of information in here, but we can see that there's things like the type of loss, the reason that the crop was lost, and if I scrolled over more, you would see other information that we'll look at in a second. And so right away, what most people might do is make a map of this. And so here, and there's nothing wrong with this, this is a map showing crop type. And so we can see some patterns, but really all we've done is made a map of our points. And we've added a legend so people can start to interpret a little bit, but there's so much more information behind every single point on that map. And so if we bring that data into CARTO before we make that first map, one of the things that we can do is begin to explore that information. And you might be a data scientist like Stuart was talking about, who could do a lot of crazy different things to explore their data, or you might be more like a person like me that is more visual and kind of wants to see the information and pan and zoom my map and kind of understand my data a little bit better in this way. And so here what we're seeing as this video is playing is in different times I'm zooming the map, I'm panning the map, I've added a series of widgets for the different attributes in my data. And as I do these actions on the map, what I'm seeing is the information update on the right-hand side. And so at one view, what might be the cause for the most loss of crops is different at a different view. And I think I end up zooming out here eventually, and what we can see by even ordering the data in our widgets is that most crops were lost due to drought, and the crop that was most affected was wheat. Okay, so now we have a little bit more information for our map. And we can make something that tells a little bit more of a story. So here I've kept the color as the crop type, like we had in the first version of the map, but then I've sized each symbol by the amount of the loss. And I've also added the widgets, and I've ordered them. So here we can see what I was saying, that drought was the cause for the most crop loss, and 16 million acres, and the crop that was most affected was wheat. I also have a time series widget on the bottom there going from January of 2017 to December of 2017, and so we can kind of see the distribution of crop loss over the year. But again, there's still information that we're not able to put in a map symbol. And so using a tool like Builder, we're not limiting you from what you can actually symbolize. So what I'm doing here is clicking on a category widget, and specifically that teardrop icon. And so now my map has gone from a map of crop type to the cause of the loss. And so now we can begin to see different spatial patterns when we look at the reason for the loss. Okay, so that's the map creator. You made this map, and now you're going to publish it. So that means that this map is now going to be used in a lot of different ways that you don't know about. And the really cool thing about a tool like CARTO is that this one map can become many, many, many maps. So every time I filter an attribute, or I zoom, or I pan, or anything, CARTO is saving that URL state. So even though I thought that I made a map of crop loss by type of crop, somebody else will use that map and tell a different story with it. For example, which crops were most affected by hurricanes and rain in 2017? Or which crops specifically are we talking about when we're talking about crops that were lost due to drought? Okay, so this is where we are today. And it's really exciting, and I actually wanted to take a survey of people that have used Builder to create these kinds of map stories, and just a show of hands here. Okay, so great. A lot of you know how awesome this is. And I think that it's almost so awesome, and understanding all of the functionality inside of there is sometimes, you know, a little bit challenging, but keep exploring because there's so many cool things that you can do. But we still have a couple of challenges. And from a cartographic perspective, I want to talk about those, from my opinion, in a cartographic perspective. So when we think of a web map, and specifically focusing on the map part of a web mapping application, we have a map, okay? And so typically what you'd see is the map in the center. But really what that map is composed of is two different components. We have the base map, and then we have a data layer. So in traditional cartography, you would call these a reference map and a thematic map. And they're two very different things. And the way that you symbolize them, the way that you symbolize the data, the visual variables you use, everything is so different between the two maps. But what we've been doing on the web is considering them pretty much the same, especially in technology. And I'll show you a little bit more about that. So if we break it apart and just look at the base map, when we're zooming into a base map, what happens? You get more and more information, right? You don't just keep zooming into the same map. Whereas when you put a data layer on that exact same map and you zoom in, you're getting more information on the base map, but you're not actually getting more information about the data layer. And so what's happening here is we know a lot about the very specific location we're in, but we can't relate our data layer to that location because we're actually not learning more as we zoom in. So that's one of the challenges, is this kind of base map cartography versus cartography for the thematic layer. And again, remembering that they're two different map types. And with the thematic layer, there's a lot of really cool things that we want to be able to do that are challenging. I just have a few examples up here of some more, what we could say are advanced visualizations of thematic data. So it's not necessarily that you would do this with a roads layer, let's say, but if you're looking at something like cholera or the opioid crisis or precipitation, there's a lot more information in there that you'd want to symbolize in different ways to communicate your message. And so the reason that this is challenging, like you can do this with CARTO CSS, but CARTO CSS and a lot of the map styling languages that we've been using for a long time were designed specifically for base map cartography. And so we're falling into a little bit of a challenge here because we're getting all this cool data, we're doing all this really great analysis, we want to visualize those insights, but what is sometimes a blocker is actually being able to style that. And that shouldn't be the case. Everybody should be able to make these maps. And so what are we thinking about at CARTO for the future? And we've seen a lot about CARTO VL today, and it's actually really exciting. And from a cartographic perspective is where I want to talk about it mostly. So it's a vector library composed of a lot of different pieces. So thinking about the cartography piece, really one of the challenges that we're addressing is this: what is multi-scale thematic cartography and what do people want to be able to do? So I actually don't have the really beautiful, amazing, awesome examples, some of the ones that we saw today, but I wanted to kind of show these more general examples. So one of the things that we might want to do as we're zooming in and out of a map on the data layer is change the symbology. So here I'm interpolating, and interpolation is something that you can't do with CARTO CSS. So I'm going from red to yellow, and the colors in between are being interpolated. We can add on top of that. So in addition to interpolation, I might want to start introducing additional information about that thematic layer as I zoom in. So when you're zoomed out, maybe having all of the symbols sized isn't the best decision, but you should be able to make the decision when you want to do that and how you want to do that. And so using things like expressions, for example, here I'm sizing the symbols based on a numeric attribute, and they're proportional to the value because I have now available to me square root, which is something that's not available in CARTO CSS. I can do that. And then you can go even more crazy and combine some other things like animation. And so here what we're seeing is basically the first two concepts building up. So this map is interpolating the time of the day through the color and the animation. So when it hits the bright pink, that means that we are at dawn. And then it goes through showing tonight to the darkest color. And similarly, we're sizing the symbols proportionate to the amount that was spent. And at each zoom level, you'll notice that my symbols aren't getting smaller and smaller, but actually staying proportionate to the zoom level I'm looking at. And I don't have the VL styling up here, but really this is about 2 lines of styling. And so what we're really trying to do is make this not intimidating and easy to use, and we want you to be able to make really, really awesome maps with it. So speaking of awesome maps, I'll just show you a couple of things that maybe you didn't think were possible without really having to be an expert in data visualization on the web. So this is an example of drought data for the year. Well, it's from January 2018 to the last week in April of 2018, animated over time on the web. And this is using interpolation to animate the data at each interval of the week. So at each week, sorry. We can also now start doing things like animating lines. We're at the New York locations, but we also had one in Madrid, and these are all the people that came from the different places to Madrid for that conference. And this was the first time a lot of us in the office had actually seen a map of animated lines, and it was like really awesome. I mean, not the first time we had seen it, but the first time we were able to make it easier. And then, you know, for the advanced symbology, this is just an example of using rainfall data from Hurricane Harvey aggregated to the county. And each county is colored by the total amount of rainfall that it got over I think I only am showing 2 days. And then I'm doing something else. I'm using opacity to make a value by alpha map. And how I'm doing that is to basically assign more opacity to counties that have higher populations and less opacity to counties that have lower populations. And so what's happening is I'm animating it. So it's not really animating by time even. This animation is actually happening by the amount of rainfall. And my colleague, Raul, is going to be giving a talk tomorrow about technology trends in the LA world. He's the head of technology at CARTO, and he's going to be talking about CARTO VL a lot more. So I just wanted to give you a brief overview from the cartographic perspective about what you can be really excited about and the things that are already in your hands. I know Sancha and I think a couple of other people mentioned the Developer Center. So please go there. We have been putting together a lot of examples of VL, and find us, ask us questions if you're interested in trying it out. And thank you.